All right, welcome back, everybody. We are here going through direct and inverse variation. Please be quiet on the side over there. Direct variation is going to be divide, and inverse variation is going to be multiply. Multiply. There we go. Got a little distracted. Here's what's going on, okay? Totally new vocab. We haven't heard the word direct when it comes to math. We haven't, maybe we have a little bit, heard the word inverse when it comes to math. And we definitely have not heard the word variation when it comes to math. Now, here's the important part, okay? We're going to be looking for, glad you made it. Start throwing away. We just got notes on your desk. Get started on the notes today. So, we've got variation, direct and inverse. We have to tell the difference, okay? I'm going to give you a question. If you look at number 1, it says decide whether it is direct or inverse. So you got to know the difference. And the good news is they are very different. And so it really shouldn't be that hard to tell. We have y divided by x equals k. I hear you. Yeah, equals k. Over here we have y times x equals k. You might be thinking for yourself, why are we using k? What the heck is k? What, we haven't ever used k before. K is just a number.
What? Just a number. Okay, you just bought it.
Okay, you gotta come up with either more jokes or, just be quiet for me. Hearing the same thing over and over again is driving me a little crazy. So, here's what we got. If you see a K, basically just ignore it. It doesn't really mean much. Don't let it scare you. K is just a number. So if you look down here, you won't even see K on a normal question. It'll just say y equals 3x. The 3 right there, that's the K. The 3 right there, that's the K. The 5 is the K. All right? Basically, if you see a K, don't let it scare you. What matters is the y and the x. Divide them for direct, multiply them for inverse. Now, here's the best news. We live in the age of Desmos, which means we don't even really have to learn about this like kids used to, and we don't have to do any multiplying like kids used to. Here's what we got to do. We want to memorize the graph, all right? This is about 80-90% what you want to be learning today. When it comes to the graphs must be a straight line that goes directly through 0, 0.
Well,
so, if we're talking about straight lines that go through 0, 0, do you think that counts as a straight line that goes through 0, 0?
Yeah.
I agree with you. Now, what about that? Is that a straight line that goes through 0, 0?
Yeah.
Yep, I agree with you. This is also a straight line, and it's going through 0, 0, right? This is where we're trying to go through, right there, 0, 0. What about this? Is this a straight line that goes through 0, 0? Yeah, so there's a lot of straight lines that go through 0, 0, okay? It doesn't matter if they look like they're going down, negative slope. It doesn't matter if they look like they're going up, positive slope. These are both direct variation. So, let's go ahead and draw one. I can draw one like this. How does that line look? Nice and straight through 0, 0, aka the origin. So yeah, there we are. Doesn't really matter all that much. Now, I do want to point something out for you. This is a question that everybody misses. It sounds so silly. Looking at this red line, is this red line a valid direct variation line?
Yes.
Heard a yes, heard a no.
It's no.
No, it's not touching TLC.
It has to be two things, straight and through the origin. All right? So this red line right here is a fail because it does not go through the origin. This red line right here is bad. It's wrong. Okay? Now, moving over to the inverse. Now, here's the thing about inverse. The graph looks crazy. And you might think, I'm about to draw it, Mr. Collier, what the heck am I looking at? This is a crazy graph. Here's the good news. Wilson's here. Let's face forward. You don't have to know everything about the inverse graph. You just have to know that it's different from a direct graph. Okay? So, you have to be able to tell the difference between a straight line that goes to the origin and this graph. Comes down and then goes over. Comes over and then goes down. Now, again, if you think to yourself, whoa, Mr. Collier, this is crazy, man. That's a ridiculous graph. I don't like the way that looks. You don't have to, know everything about this graph. What you have to know is that this graph is different from this graph. Now, do these graphs look anything alike at all? They don't have anything in common. They literally are complete opposites. So, you got to tell the difference between something very, very normal and something that looks absolutely ridiculously alien. Okay? Now, teachers try to come up with a name for this so that you can remember, oh, look, that looks like a weirdo graph. But it's very hard to come up with a name for this. If you had to, name this kind of shape, anybody got, what does this look like to you? Yeah, but it's like, it's two L's. So here's the best that they got. Other teachers like to use boomerangs with an S because there's two of them. You guys know what a boomerang is?
No.
It's a nice weirdo curved thing that you throw when you're like in Australia or something, and you throw it and it comes back. Now, with this, I think boomerangs is good enough. I like to think of it like a snowy window. You guys know how snow kind of collects on a window and makes it kind of look a little bit like, you snowed in. And if you think about the axis here, the y-axis and the x-axis, and you think about that like the window frame, and then you got the snow that kind of collect. I don't know. Maybe I'm crazy. I like to think of it like a snowy window. Either way, boomerangs, snowy window, weird curvy L things. Again, you don't have to know everything about this. You got to know that this crazy graph is different than this boring straight graph. So, let's see it. What we're going to do is decide whether this is direct, inverse, and importantly, possibly neither. Neither is an option. So, looking at this, the first question says y equals 3x. I'm going to Desmos. I've got y equals 3x. What do you think about number one? Does this look direct? Does this look inverse? Or does this look neither? It should be painfully obvious which one number one is. This is a direct graph. So, if this is a direct graph, it's going right through the equal sign, right through the origin, a nice straight line. You guys won't be going tomorrow, just a heads up. You. Yes. Number 2, we've got y equals x divided by 3. Y equals x divided by 3. Go to Desmos. Type it in. Y equals x divided by 3. How does this look? Direct or inverse? It should be so easy, so obvious. This is a direct variation because it is a straight line that's going right through the origin. It doesn't look anything like an inverse. Honestly, if you're waiting for me to write direct, then you're struggling. I don't know what to tell you, okay? It's a straight line. Now, number 3, which is y equals 5 divided by x. Does that look like a nice, boring, direct graph? Or is this a crazy boomerang, snowy window type thing? This is an inverse graph. All right. I'll give you a little challenge. Number 4. Can you do number 4? What do you think? Anybody figure it out? You can shout it out. Dude, type it in. Look at the picture, man. It's the easiest question we've done all year almost. You got Desmos? You might want to try doing something today. Type it in. Look at that picture. See what you got. So for number 4, type it in. No brain. Y equals 7x minus 2. There's our picture. Does that look direct? Does that look inverse? This is actually neither. I even said you got to be careful. Everyone misses this question. This is neither. We have a problem with this graph. Does it go through the origin? It does not. It does not. And so we have a fail. We have a neither. I'll even write myself a little bit of a hint here. Not through origin. As easy as that is, that will be the most missed question on the classwork, unfortunately. All right. I'm going to give you a minute to try to solve 3 questions here on you. You got a minute. Thank you for going quickly. All right, you got a minute. 3 questions. We're doing them. 5, 6, 7. We're math class. 5, 6, 7. We're typing them in. There's no brain involved. Sincere, do you need a pencil, man? You good? Sure. Didn't you have one for the warm-up, man? What's up? This that we're doing right now is the nose. Yep.
Straight down, right? That's needed.
Is it a straight line through the origin? Okay. I'm sorry. You asked a question. What was up?
On number 7, I showed.
Well, let's see. So for number 5, we got x equals 4 divided by y. How does this look? Inverse, obviously, right? It's. I heard that the next one is direct. A equals 12b. Let's try that out. A equals 12b. How does that look? Looks like a nice straight line. Does it go through the origin? Yes. I think that's looking good. That's direct. Now, what about 7? 7 says AB equals 9. And I heard it doesn't graph it, and I agree with you. I don't see the graph. If I look over here on Desmos, it gives me a yellow triangle. That's an error. That's a warning. And it clearly says we only support implicit equations of x and y. What does that mean? That means we got a problem. AB is not going to work. So what do? XY. That looks inverse to me. Always a good idea. If you're going to type it into Desmos, just make it an X and a Y. Okay? Okay. Now I said that this is about 80% of what you got to learn. The difference between a straight line and these crazy boomerangs. Here's the last 20%. All right? This is harder. I'll be honest with you. This does require a brain, which is a step up from the last 7 questions we did. All right? Now, when it comes to these questions, we're going to be looking for 2 things. They're either all going to divide to the same number, or they're going to all multiply to the same number. Okay? And if we remember up here at the top, direct means divide and inverse means multiply. So direct means divide and multiply means inverse. Okay.
Wait, no, inverse.
If you write this down, this is like the entirety of the rest of the notes. We're going to do these last 3 questions. And they don't require much of a brain. Okay? You don't have to write down very much. You don't have to think about much. But you do have to know what's going on. These are, I said this is going to be the most missed question because it doesn't go through the origin. This is most missed question number 2, 3, and 4. All right? Right underneath that one is going to be these ones. Here's what we're going to need to do. We're going to look at this table, and we're going to think at all 3 of these points. Okay? If you want to be direct, then divide, 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 you better get the same number every time. If you want to be inverse, multiply, 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 you need to get the same number every time. So, looking at this right here, do you want to try either one first? Do you want to try multiplying first, or do you want to try dividing first? Sure, we can try multiplying first. If I want to try multiplying, what is 2 times 9? We can probably do that one in our head, but 2 times 9 is 18. All right. Now, what that means is we better get 18 for every single multiplication. We better get 18, 18, 18. What is 8 times 36? It is not going to be 18, right? 288. Okay. This right here, this is a fail. Right? This is going to be not multiplying, which means not inverse. Now, that doesn't mean it's guaranteed to be a direct divide question, because maybe it's neither. So let's try divide. And it really doesn't matter which one's on top. You just got to be consistent here. So do you want to put the X's on top, or do you want to put the Y's on top? It really doesn't matter.
The Y.
Okay, if we put the Y's, just make sure that all of these are on top. So when we do our dividing, 9 divided by 2 is 4.5. And we can make it a fraction or we can just leave it 4.5. That number doesn't really matter. We just need all of them to be 4.5. 36 divided by 8 is 4.5. Notice, this is better, but we're not done yet. They all have to be 4.5. 72 over 16, 4.5. All right. So what we've got, 4.5, 4.5, 4.5. That means dividing worked. That means this is a direct variation. Now, like I said, this is a little bit harder. But this is not, I mean, you just type them in Desmos. 2 times 9, 8 times. Like, typing things in Desmos is not hard. We can totally do this. Okay? Just try one first. It doesn't matter which one you try. Just try it. Maybe it works. Maybe it doesn't. Let's do number 9. We're going to speed it up a little bit. I'm going to do these. Do you want to do multiplying or do you want to do dividing? Doesn't matter. So, we got people out, but what do you mean you want me to? Imani's ahead of you even, so I'm not going to accept it yet. So, what we've got here, I heard somebody say multiply. Sure, let's try multiplying first. And we might be able to do these in our head. 3 times 16. And maybe we can. Let's try. 3 times 16, 48. What about 6 times 8? 48. What about 24 times 2? That's the easiest one. Ooh. 24 times 2. 48. So we got 48, 48, 48. That means multiplying is a success. That means we have inverse. Last one here. Quiet, please. Last one. Do you want to try to multiply these or divide these first? Doesn't matter, just pick one. Multiply, divide. Sure, I heard multiply first. I think we can do these in our head. What's 1 times 15? 15. What's 3 times 5? 15. Multiplying is going really good so far. What's 15 times 3? 45. Is that a success or a failure? That is a fail. Multiplying is a fail. That means inverse is a fail. What about dividing? Now, dividing is hard to do in my head. I'm going to use Desmos for dividing. When it comes to dividing, I'm just going to make the fractions the way they look right now, which is 1 on top of 15, 3 on top of 5, 15 on top of 3. How do those numbers look? Are they all the same, or do we have a fail? We got another fail. And if you fail both, not inverse, not divide, that means you are neither. All right. Your notes look a lot like the classwork. The classwork is on Canvas. As soon as you finish the classwork, it will give you a grade right away. And that will be the grade that you got on the assignment. Your warm-ups are going to go towards a little warm-up grade for the week. So this won't be the only warm-up that we collect all week. Just a reminder, you have to go through the origin for a direct graph. If you don't, even if you're a straight line, you are still a fail.